All right, so hello and welcome. Here we go. Wait a few seconds to get the audio here. And I'll keep going. 1, 2. Wait a few seconds to get the audio. Got it. Get the chat out. Okay, so got more questions to go through here. More questions to go through. The plan is to get to 1,000 and then move on. I don't want to spend so much time on these questions, man. So much time. It's way too much time. And I have other things I got to do, quite frankly. That's the problem. I would spend the time on these things, but these other things are much more pressing. And cause me like physical pain at times. It's really like I can't spend that much time. Yeah, unfortunately. Would like to, but what can you do? Can only do so much, you know? You can only do so much. So number 1209, remove all adjacent duplicates in string 2. You were given a string s and an integer k. A k duplicate removal consists of choosing k adjacent letter and equal letters from s and removing them, causing the left and right side of the deleted substring to concatenate together. We repeatedly make k duplicate removals on s until we no longer can. After the final string, return the final string after all such duplicate removals have been made. It is guaranteed that the answer is unique. So k is 2, there's nothing to delete. K is 3, so we delete 3, and 3, and 3, and 3. We're left with A and A. Oh, okay, that's interesting. So I think you could use a stack for this. Stack-based solution is pretty solid here. You could do it in linear time, I believe. First delete E, and CCC, get D, D, B, 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 D, A, A, then delete B, 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 get D, 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 A, A, finally delete D, 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 get A, A. Yeah. And here K is 2. Oh, K could be quite large. It actually doesn't matter how large K is, though. You can still do this in linear time. Yeah, okay, it's a pretty high submission rate with a pretty high acceptance rate. This is, I think, not that hard. Stack-based solution works pretty nicely here. Okay, so let's do that. So let's use a stack of strings. Let's go character by character. And we're going to say if st.empty, or actually no, we'll just say push the empty string, right? And we're going to say st.top plus equals character. So if st.top dot size is greater than or equal to k, then we're going to st.pop. I should probably just have an if statement here. If st empty, then st.push an empty string. Okay. Then I think we just return st.top. I think it's that simple. Runtime error, no kidding. Wow. Of course. Really? What? K could be 1, right? Yeah. If it's empty, return the empty string. If it's not, then return st.top. I did this wrong. No, you don't do it this way. Don't do it this way either. So if it's empty, push something on there. If sttop dot empty or it's the empty string, or if the back is equal to ch, then we add this character. I think I always add this character actually. I don't need a stack for the. Do I need a stack? I think if I see a new character, I want to create a new element on the stack. That's what it is. That's what it is. So if st empty or st top dot back is not equal to ch, that's what it is. Then st dot push ch. That's what I want. That's what I want. Actually, should be push the empty string, and then yeah. So if it's equal, we'll push a character on. If it's empty, we'll create a new. Yeah. Okay. I think that's what it is. And then we pop if we go above k. Okay, and at the end of this, I'm going to say string result each. I did this wrong. While stack is not empty, just take the result plus equals stack dot top, stack dot pop, and then I think reverse the string. I think I need to reverse it. Something like this. Let me try again. I'm not really explaining it all the way through. In my mind, I'm thinking this is a lot easier than it is. Oh, yeah, it worked. Okay. Yeah, I think that's it. Let's try some random string sequences. Let's do like 10, 1, okay, it has to be at least 2. 2, 200, and like 1,000. 200 is too much, but let's do like 15 or something. I don't know, like 3. Something like this. Yeah, I didn't really explain it exactly what's happening here, but it's something along these lines I think will work. Oh, doesn't have any do. Those aren't good example. That's not a good example, huh? Gee. Yeah, I mean, getting good test cases for this is probably kind of tricky. Okay. Deep breath. Literally none of them have 5 or more. Gee. Okay, let's try this one. Okay. Yeah, I don't know. I think this is fine. I think this is fine. I'm gonna go for it. I'm gonna go for it. Could be wrong. We got it. Nice. Very good. All right. I'm gonna submit it 4 more times, and then I'm on to the next question. I didn't really explain this. I mean, it's basically just I don't know how else to. I don't really know how to explain it actually. I don't know how to explain it. It's kind of like a recursion, but you're using the stack instead of the recursive part of the algorithm. And that's sort of the idea. You just fill part of the stack with what you need. Actually, it doesn't need to be a string each spot. You could use other things other than a string, maybe to optimize. This is like a little bit slower than it probably could be. Yeah, basic stack-based solution. 1, 2, 3, 4, 5. We'll do one more. So if you like the video, give it a like and subscribe for more. Forgive me that this explanation wasn't that great. I think it's not too hard to understand what's going on here, though. Basically, when you see a new character, you add it to a new part of the stack, and then once you've reached k elements that are the same, you can pop that off the stack and remove it altogether. And then the new elements you add are going to be on top of the previous portion that you may or may need to want to pop. And that kind of handles the concatenation portion of this nicely. Yeah, and then as it turns out, because you're using a stack and putting things on the stack, you actually want to create the string in reverse. And it just so happens that because the elements are all they're all duplicates, you don't need to do any reversing of the individual strings, but you probably would actually reverse the string as well before you add it. The top part would reverse this before you add it to the result as well, and then perform the reverse. I suspect that's the case, but because they're all the same character, you don't have to worry about that. But yeah, the reason why you reverse at the end is because of the you're adding things to the stack. So in order to get them out of the stack, it goes in the other direction. You got to reverse it one more time. So hopefully that makes sense. All right, thank you. Yeah, as I said, thank you for watching. Give the video a like if you like it, and subscribe for more if you like more. Take care.